Welcome back to the Python coding session. Today I'll be talking about average perceptron. Average perceptron runs the perceptron algorithm on given set of data. It runs t iteration through the data set, and there is no need to worry about stopping early. The arguments average perceptron takes are feature matrix and numpy matrix describing the given data. Each row represents a single data point, labels, an NumPy array where the kth element of the array is the correct classification of the kth row of the feature matrix, T, an integer indicating how many times the perceptron algorithm should iterate to the feature matrix. Average perceptron returns a tuple where first element is a NumPy array with the value of average theta, the linear classification parameter found after t iteration to the feature matrix, and the second element is a real number with the value of the average theta, null, the offset classification parameter found after t iteration through the feature matrix. Hint: it is difficult to carry a running average, however, it is simple to find sum and divide. So that's the introduction of the average perceptron from the code itself. Now, moving on to our coding part, how do we do this? For this, we need to define a few variables. And what are those variables? Those variables are current theta. Then we have to store the sum of all the thetas across t iteration. It's going to be theta total, and there's going to be current theta naught. And also we have to store the theta naught total across t iteration. So there's going to be 4 different variables to start with. Typing current theta, it's going to be equal to numpy and we're gonna populate that with zeros. The dimension of this is gonna be one. It's gonna be one row, and feature matrix. How many columns the feature matrix has? It should be that many columns. Feature matrix is a input value, input matrix, and shape of that is gonna be whatever the shape of that. So we need this many columns for that. Same with the total. So we want to store all the sum of these into one numpy array, and we need to initialize that in first place. And it's going to be same. Next step is to define current theta naught. Current theta naught, we'll start the calculation with current theta naught as 0, and then we have to define an array out of that. Here, theta naught total is a is actually a list that where you append the current theta as you go on, and you do the mean on top of that. So that's what theta total is. Or we can just say theta is equal to 0. That should be it'll be a more consistent. Now we have to iterate through the feature matrix. Second is go e in. Now let's get the order from the feature matrix. Feature matrix dot shape. So what happens is that it will give you a iteration out of the feature matrix in different order every time you iterate to it. So we'll iterate in different pathways. It won't be in the same order every time we iterate to the feature matrix. First, we need to invoke the perceptron single update function, and that intakes feature matrix. That intakes the feature matrix, and it also intakes a label. Where we are sending the each data point into through this function. I is the data point, another data point, which is a label, labels, labels. It is labels. Okay, labels. Third step is to do the current data. Current data. Initialize the current data and current data not. This gives us this gives us theta, the two-part component. There is current theta and theta not, and we'll extract the theta and theta naught from this and assign that into respective variables. Let's define this again. And it's going to be 1 here. And let's assign these to respective variables. Current theta and the current theta naught. That's going to be it. We need to assign it to respective variables here. Well, where is complaining here? And it says current theta is not defined. Currenta. It's not current, it's currenta, right? Perceptron single update. Here we are invoking perceptron single step update twice and assigning instead of doing this, right? Why do you invoke a function twice? Why don't we invoke the function one time and break that into two different parts? That would be much cleaner, I think. So let's try that. Theta. So we have here perceptron single update, step update. We invoke that and we break that into two parts. Here we break the theta into two parts and assign that into respective variable, current theta and current theta not. This is much more cleaner actually. This is much more cleaner. Once we do that, next step is to sum these up. Let's do that. Theta total plus equal to current theta, theta total plus equal to current theta not. Here we have total these two variables into their respective totals. Next step is to return the average. How do we do this? We'll type return theta total, which is a matrix numpy array. We'll just divide by t. And secondly, the theta total will just divide this array by t. The theta total divided by t. If you do that, then we have produced average for theta, current theta, and current theta not. Now let's quickly summarize what we discussed today. We discussed about average perceptron function, and this function is supposed to go through the feature matrix t number of times and produce the average current theta and theta naught to the outside world. Thank you so much. See you later.